But for car-based unibody utility vehicles like RAV4, Highlander, and Sienna, Toyota instead offers exceptionally capable all-wheel drive systems for added traction in loose or slippery conditions. These all-wheel drive systems send variable power to the front and rear axles, with the front differential, center differential, and transfer case all incorporated into one compact unit up front, and a rear differential located at the rear axle. These systems rely on sensors to detect wheel spin. When wheel spin is detected, a specialized electronic control unit, or ECU, applies the brake to the spinning wheel, which sends power back to the wheels for traction. Sienna's all-wheel drive system is called Active Torque Control All-Wheel Drive, while Highlander and RAV4 systems are called Dynamic Torque Control All-Wheel Drive. Both active and dynamic torque control systems use an electromagnetic coupler to vary the amount of power that goes to the front and rear axles. Now, during normal driving, these systems default to front-wheel drive mode to optimize fuel economy. But as road conditions change and more traction is required, this system can engage the electromagnetic coupler to allow engine torque to flow through the rear differential to the rear wheels. For example, during acceleration, tight cornering, or slippery conditions where the front wheels begin to lose traction, the all-wheel drive ECU varies the amount of amperage sent to the electromagnetic coupler and allows more power flow to the rear wheels for added traction and stability. The amount of torque can vary depending on traction requirements. The dynamic torque control all-wheel drive system in Highlander and RAV4 considers wheel speed, steering, and throttle feedback to adjust the power flow just like Sienna's active torque control system, but also looks at the vehicle's yaw rate. That's the rotation around the front and the rear axis of the vehicle to further enhance handling and control. RAV4 Hybrid and Highlander Hybrid use a unique all-wheel drive system with no mechanical linkage between the front and the rear axle at all. This system is called...
These two systems are a little differently, so I'm going to cut the video off there. This relies on a separate motor in the rear, which it'll actually send power directly to the back. So this is the hybrid version. So once again, I'm going to cut the video off there. Just want to make sure you had a little bit of an idea as to how the all-wheel drive system worked in it. You know, I find it very important, like I said, because of reliability. And like I said, there's no essential cutoff at 30 miles an hour. That just doesn't exist. We do also have a lock for the rear differential in case you do feel like you need some additional traction at the speeds under 25, to where you can actually engage that and force more traction to those back wheels. Essentially, rather than the car determining it, you're forcing 50% power to those back wheels. So just wanted to make sure that you understood that. You know, it's just some great information for you.
Meaning they default to front-wheel drive to help maximize fuel efficiency and automatically engage their all-wheel drive capabilities when additional traction is needed. These systems are best suited for enhancing traction and stability on loose or slippery surfaces and are not intended for extremely technical or challenging off-road conditions. This wraps up our series on four-wheel drive and all-wheel drive. We hope you enjoyed the videos and learned a lot about Toyota's drivetrain systems. Thanks for watching.